Hey guys, this is the Algebra 2 sections 1 through 3 of Chapter 6 review. So number 1 says, what is the simplest form of the expression? Well, first of all, we can't add or subtract any of these radicals because we don't have the same radicand. We have the same index, which is 2, 2, and 2, but we need this number inside our radicand to be the same. So the first thing is we need to break it down using our border method. So 175, starting with 2, 2 doesn't go in, 3, let's see, 3 goes in, 5, nope, 3 doesn't go in, so 5 goes in, 3, 35 times. Sticking with 5, that goes in 7 times, and then 7 goes in once. All right, so we have a pair, and we need a pair since our index is 2, we need groups of 2. So a 5 comes out, and a 7 stays home. So this is really now 5 square roots of 7. Now breaking down the number 28. Starting again with 2, 2 goes in 14 times, 2 goes in 7 times, and 7 goes in once. Again, we need a group of 2, so we have 2 2s, that one comes out, and the 7 stays in. Our sign here is a plus sign, and so we're going to cross that one out. Lastly is trying to break down the square root of 7, but that's a prime number, so we can't break that down, so I'm just going to write minus, and my coefficient here is 1, so I'm going to put a 1 out there, 1 square root of 7. Now I can combine. My like term is the square root of 7, so you keep your like term. So I'm going to keep, this is going to be equal to that square root of 7. But then we're going to take our coefficients and we're going to add or subtract them. So 5 plus 2 is 7, minus 1 is 6. So the simplest form is going to be 6 square roots of 7. So your answer here is C. Moving on. Alright, number 2 says find all the real square roots of 0.0049. Alright, so square roots lets us know that we're trying to find a number times itself. So what number, when you square it, is equal to 0.0049 is what this wants to know. So what you do is you just take the square root of each side to undo that square. So the square roots would be 0.07 or negative 0.07. So these are our real square roots of this number. So both the positive and the negative. Number 3 says find the real number root. Well, for number 3, we have an even degree. Our degree here is a 2. I'm sorry, an even index. It's a 2. And we have a negative radicand. Now, if you have an even index and a negative radicand, then your answer is no real roots, because our roots are imaginary. You're allowed to have a negative radicand if you have an odd index, and then that just means that you'll have a negative answer. Like number 4. Number 4, we have an odd index, and we have a negative number. So that just tells us that our answer is going to be negative. And then all we do is we take the cubed root of 27, we take the cubed root of 64, we take those separately, and we get negative. The cubed root of 27 is 3. 3 times 3 times 3 gives you 27, and the cubed root of 64 is 4, because 4 times 4 times 4 gives you 64. So our answer is right here, negative 3/4, and this was our answer for above, and this was our answer here. Alright, number 5 says, what is a simpler form of the radical expression? Okay, so what we want to do here is break down each term individually. So notice that our index is 4, so in order to leave this radical, you need to leave with a group of 4. Your number is 625, and we're just going to break that down. So we know 2 doesn't go into it since it ends in a 5. We know that definitely 5 goes into this. So 5 goes in 125 times, and then 5 goes into 125 times, 5 goes into 25 5 times, and 5 goes into 5 once. Perfect. So in order, again, to leave this radical, we need a group of 4. And we have a group of 4 5s. So a 5 comes out, and there's nothing left to go inside. So we won't have a number that goes back inside. Now we deal with our x's. We have x to the 20th. Well, all we're going to do is ask ourselves, how many groups of 4 can you make of 20? So we have 20, and really what we're going to do is say 20 divided by 4. And we can see that we make 5 groups. So x to the 5th is what's going to leave. We can make 5 groups out of those 20 x's, 5 groups of 4. Then we have y to the 32nd. And again, we want to know how many groups of 4 can we make. So we're taking 32, and we're dividing it by 4, and we get 8. So we can make 8 groups. So y to the 8th comes out. And again, there's nothing left over. There's no remainder. So this is my final answer. I have nothing left to go back inside of the radical, so I don't even need to write the radical. So my final answer here is 5, x to the 5th, y to the 8th. Number 6 and 7. These say multiply and simplify if possible. In order to multiply, you need the same index. Our indexes are 2 and 2, so we're able to multiply here. So for number 6, multiplying these together, we get the square root of 7 times 4 is 28, 8, 2, 7 times 1, 98. Square root of 98. Now though, if we want to simplify this, we're going to break down 98. So 2 goes into 98 49 times, and then 7 goes into 49 7 times, and 7 goes into 7 once. And again, in order to leave this radical, you need to leave in a group of 2. So here's a group of 2 7s. So a 7 comes out, and that 2 stays inside. So here's our answer for number 6. Number 7, we have these parentheses, and that usually indicates that you're going to distribute. So I'm going to take this outside term and distribute to the inside. And I get the square root of 6a squared. Because a to the first times a to the first, we add that together, 1 plus 1, and we get 2. Then we distribute again. Notice there's this minus 6 on the outside, and on the outside of our first radical, we just have a 1. So the outsides, or the coefficients, they multiply together. So 1 times negative 6 is negative 6. And then the insides, our radicands, those multiply together also. So 6a times 6 gives you 36a. And now we simplify anything if possible. Looking at our first radical, 6 itself, if you try to break that down, well, 2 goes into it 3 times, and 3 goes into 3 once. And you notice we don't have a pair here. We don't have the same number, so nothing can come out. But we do have 2 a's. And in order to leave, you need 2 in a group. So we have 1 group of a's. Again, we have 2 a's. We need 2 in a group. So 1a gets to leave, and there's none left over. But we do have that 6 left inside. Breaking down this other radical, 36a, well, we only have 1a, so no a's can leave because we need 2 in order to leave. But the 36, well, we can break that down. 2 goes into 36 18 times. 2 goes into 18 9. 3 goes into 9 3. 3 goes into 3 once. So we have a group of 2's, and we have a group of 3's. So 1 2 gets to leave, and 1 3 gets to leave, and they multiply together to give us 6. So 6 gets to come out. Realize, though, that there's already this 6 out here. So this 6 that gets to leave multiplies with this 6 that's out here, and we get minus 36. And left inside is this a, square root of a. So here's our final answer. I say this is our final answer because we're not able to subtract them. In order to subtract them, you need the same index, which we have. They're both a 2. but you also need the same radicand. And this is a 6, and this is an A, so you're not able to combine them. Number 8 and number 9 says, what is the simplest form of the expression? So we basically just want to simplify it. Again, we're going to start with the 40 with just one term at a time. And in order to leave this radical, you need to leave in groups of 3. So 40, we can break it down. 2 goes into 40 20 times. 2 goes into 20 10 times. 2 goes into 10 5 times. And 5 goes into 5 once. So we see that we have a group of 3 2's. So a 2 gets to leave, but a 5 has to stay inside. Remember, the radical is kind of like a house. That's what we've been referring to it. And the index is like the house number. So we need that house number in order to identify it. So don't forget your index. Now we have 13 A's. And before I just said take your 13 and we need to divide it up into 3. 3 in a group. So 13 divided by 3, we get 4 groups. We get 4 groups with just 1 left over. So A to the 4th comes out, but that 1A is left over. Now, if you're not too sure about that, you can always draw out your 13 A's. And, draw them out in groups of 3 since that's your index. And see how many groups you have. You got 1, 2, 3, 4 groups, and then here's my 1 that's left over. Now I have B to the 9th. And again, I need groups of 3. So I'm just going to divide 9 by 3, and that gives me B to the 3rd. So B to the 3rd comes out, and there's no B's left over. 3 goes into 9 evenly, and there's none left. So here's my final answer. I'm going to shorten that radical, and I'll box this up. All right, number 9. Let's simplify that one. So again, we have an index of 3. So we're just going to break this apart and separate it one term at a time. So the number 128, we'll reduce that, or we'll use our border method. Say 2 goes into 128 64 times. 2 goes into 64 32 times. 2 goes into 32 16 times. 2 goes into 16 eighths. 2 goes into 8 4. 2 goes into 4 2. And 2 goes into 2 1. And again, we're looking for groups of 3. So here's 3 2's, and then here's 3 2's. So 1 2 gets to come out, another 2 gets to come out, they multiply together, so 4 is really what comes out. And this 2 is what's left inside. So 4 comes out, and left inside the radical is going to be the extra 2. Now I have to deal with my variables. I have A to the 16th, and I'm just going to divide that by 3. So you have 16 A's, we need groups of 3. I have A to the 5th, that means I can make 5 groups with just 1 A left over. So A to the 5th comes out, and 1 A goes back inside. Now I have B to the 6th. I'm going to take 6, I have 6 B's, I'm going to divide it by 3, and that gives me B to the 2nd. And I don't have any left over there. So here's my final answer. Alright, number 10 says, what is the simplest form of the product? So remember, we're allowed to multiply 2 radicals together as long as they have the same index. And they do. They both have an index of 2. So we can just multiply what's inside together and then simplify it then. Or we can try to simplify first each radical and then multiply. So that's what I'm going to do. I'm first going to take each one, and I'm going to just simplify this one, and I'm going to simplify that one, and then I'll multiply them together. So 245 is a really big number. So let's simplify that. I know that 5 goes into it, and let's see, 5 goes into 24 4 times, with 4 left over, so 5 goes into 45 9 times. And then 7 goes into 49 7 times, and 7 goes into 7 once. So I have a group of 7's that come out. Left inside is going to be that 5. Dealing with my variables, I have x to the 5th. So I have 5 x's. And I need groups of 2. So I got 1, 2 groups. So x squared comes out. I'm going to erase the 7, make more room. So 7x squared. And there's that 1x left over. And then again, I have 5 y's. So I've got 2 in a group, 2 groups. So y squared with 1 y left over. So I'm going to take this and multiply it with whatever I get over here when I simplify it. So 15, I know that I can't reduce that because 3 goes into it 5 times, 5 goes into 5 once, and I don't have a pair. I only have 1 x, so I can't make a pair there, but I have 2 y's. So here's one group. So y comes out, and left inside is the 15 and the x. Alright, so now you just multiply outside with outside and inside with inside. So multiplying the outsides together, I'm going to say 7x squared y squared times y. Well, the rule here is just to add your exponents. So I have 2 plus the 1, that gives me 3. So I have 7x squared y cubed now. That's on the outside. Now left on the inside of the radical, I have 5xy times 15x. So 5 times 15, 5 times 15 is going to be 75. X times x, again we add those exponents, and we get x squared, and then I have that y. Alright, so now I just need to make sure my inside radical is simplified. 75 is kind of a big number, so we want to double check that that is simplified. 3 can go into 75 25 times, 5 goes into that 5 times, and 5 goes into 5 once. So we have a group of 5, so a 5 does come out, and it's going to multiply with this 7. So when they multiply together, I get 35. Notice you have 2 x's inside, and if you have 2, and you need 2 to be in a group, then 1 x gets to come out, and it comes out, and there's already, though, these 2 x's out there. So now we have a total of 3 x's. We only have 1 y, so that doesn't make a group with anyone. So we still have y to the third on the outside. And left inside is going to be this 3 and this y. So here's our final answer. So this one definitely was a little complicated, and you want to take your time when you're simplifying and when you're multiplying and make sure that you get the right answer. Numbers 11, 12, and 13 looks like we need to simplify and also rationalize our denominator. Remember, you're not allowed to have any radicals in your denominator. So the first thing for number 11 is first check to see if you can simplify anything. So the number 56 and 7, well, 56 divided by 7 is 8, so I can reduce and I can get 8 on top. And I'm left with just 1 on the bottom. If I divide both of those by 7, then that's how I get that. And then on top I have 30 x's, and on bottom I have 1. Our rule for division is to subtract, so I'm left with x to the 29th on top, and no x's on bottom. So, in fact, I don't even need this radical in my denominator anymore. I don't have a denominator at all anymore. So I'm just left with this radical. So now, though, I need to simplify this radical. So 8, using our border method, 2 goes into 8 4 times, 2 goes into 4 twice, and 2 goes into 2 once. And again, this has an index of 2, so a group, we have one group of 2's, so 2 comes out, and then that 1 2 stays back inside. Now we have to deal with our variable. We have 29 x's, so x to the 29th. Since our index is a 2, then we need groups of 2. So you think, how many groups of 2 can you make with 29 of them? So if we divide it by 2, well, 2 goes into 29 14 times evenly, and then it has 1 left over. So x to the 14th comes out, and 1x stays inside. It's left over. So here's our final answer. Number 12. Number 12, they're both to the cubed root, so that's good because you need the same index when you're dividing. Then we have 10 over 9. Now we can't reduce that at all, and we can't simplify either of them because this is the cubed root of 9, not the square root. So what we need to do is just rationalize our denominator here. So you can think of 9, we can cross out 9 though, and we can think of 9 as 3 squared. Right? Because 3 times 3 gives you 9. So if we have two 3's already, and we have an index of 3, then we just need one more 3 to make a group of 3 3's. So I'm going to multiply by that then. I'm going to say multiply it by the cubed root of 3. And multiply the top by the cubed root of 3 since you have to do exactly the same thing from the top to the bottom. So look here, we have 2 3's here, and then we have a third one from over there. So now we have a group of 3 3's. And that's what you need in order to leave this radical because our index is a 3. So a 3 comes out, and on top we multiply and we get the cubed root of 30. 3 times 10. Now remember, this 30 and this 3, they don't reduce because the 30's inside this safe radical, and this 3's outside, so they can't reduce each other. And then this 3 and this 3, well, this one's an index, and this one's not. So, I mean, even if it was indexes, they don't change. So here's our final answer. Looking at number 13, again, we want to try to simplify before we do any rationalization. 7 and 6, we can't reduce those, but we do have x to the 10th and x to the 4th. So subtracting, we have x to the 6th, and then again we have y to the 10th and y to the 3rd, so subtracting we have y to the 7th. And on the bottom now I just have the square root of 6. If I wanted to simplify some more, I can. I could say that in my numerator I have x to the 6th, and my index is a 2. So I know that if I have 6 x's and I need groups of 2, I know 3 groups can be made. Also, if I have 7 y's and I need groups of 2, I know again that 3 groups could be made. 3 groups could be made of the y's, and there's just 1 left over. So left inside is going to be a 7 and a y. And this is all over the square root of 6. Now you're not allowed to have a radical in your denominator, so we need to rationalize it, and we need to multiply it by the square root of 6. We need to get that out of there. And what you do to the bottom, you do to the top. So on bottom, a 6 gets to leave, and on top we have x cubed, y cubed, times the square root. 7 times 6 is 42, y. And here's our final answer. Now 42, you could try to break that down, but recognize that you got 42 by saying 7 times 6. 7's a prime number, and 6 is made up of 2 times 3. So you don't have any pairs or any groups of 2 right there. So here's our final answer. Alright, numbers 14 and 15, they say, what is the simplest form of the radical expression? Well, notice in 14 and 15, we're combining by addition or subtraction. And in order to do so, you need the same index and you need the same radicand. And then you just add the coefficients on the outside, or you subtract them. Well, in number 14, we have 4 as our index, so that's good, but our radicands are different. This is a 5x and that's a 10x. So if we can break it down and try to change it to make it the same, then we should. 5 though is prime, so that's not going to change. And 10 breaks down into just 2 and 5. And you need a group of 4 to come out. So we don't have a way to simplify either of these. So this actually is our simplest form here, and there's nothing we can do about it. Looking at number 15, however, we're in better luck here. We have 3 as our index, and we have 5a and 5a. So our like term is that 5a, is that cubed root of 5a, so we're going to keep that. We're going to keep that cubed root of 5a, your like term, and we're just going to say 5 minus 3, and we get 2, and that goes on the outside since it was on the outside. So here's our final answer. Looking at number 16, it says a garden has width of the square root of 7 and length 5 square roots of 7. What is the perimeter of the garden in simplest radical form? Well, this is just perimeter, and I guess we're to assume that this is a rectangular garden. I don't really see any proof of that, but that's going to be the assumption that I'm going to make since it says width and length. So to find the perimeter, I'm just going to add up the width and the length, and then the width and the length, because perimeter is equal, for a rectangle anyways, to twice the width plus twice the length. So we're going to, assuming that it's a rectangle, say the square root of 7 plus the square root of 7 plus 5 square roots of 7 plus 5 square roots of 7. Well, again, our like term here is the square root of 7, so we'll keep that square root of 7. That's our like term. And now we're just going to add the coefficients. So even though it's not shown there, I know this has a coefficient of 1. This has a coefficient of 1. So 1 plus 5 is 12. So I have 12 square roots of 7. Number 17 and 18. This says, what is the product of the radical expression? So product means to multiply. Product indicates multiplication. In 17, it doesn't look like we're multiplying by anything because we have this exponent of 2. But what that really means is that we have negative 3 minus the square root of 6, and we have it twice, negative 3 minus the square root of 6. So just make sure you write it twice. And now we're going to go ahead and FOIL this out. So we're going to say first times first. So for my f, I get 9. Then outside times outside is a negative times a negative, so it's a positive. And 3 is on the outside, and that 6 is on the inside, so they'll stay there. Inside times inside, again, negative times negative, so positive. 3 is on the outside, 6 is on the inside, so they stay there. And then negative square roots of 6 times negative square roots of 6. I have a negative times a negative, so it turns to a positive. And then the square root of 6 times the square root of 6 is just 6. So now combining like terms, we can say 9 plus 6 is 15. And we can combine our insides. The square root of 6 is the like term, so that stays. And then 3 plus 3 is 6. And this is our final answer. I'm not able to combine the 15 and 6 here because this 6 is attached to the square root of 6. That multiplication has to happen before I can do any type of addition. So here's your final answer. Let's look over at number 18. Notice in 18 that they're exactly the same, just one's a plus and one's a minus. This means that we have conjugates. And when you're multiplying with conjugates, you don't have to do all of Florida or all of FOIL. You just have to do Florida. So we're going to say first times first, and we get 36. And then last times last, positive times a negative is a negative, and the square root of 2 times the square root of 2 is just 2. And now when you actually simplify this, we get 34. So 34 is our final answer. Alright, finally, our last two problems. So it says, how can you write the expression with rationalized denominator? Looking at number 19, we have the square root of 5 plus the square root of 7 in our denominator. Now we have that same thing in our numerator, but with a minus sign. Well, we're not multiplying here, so there's nothing special about that. Like, even though they're conjugates in the numerator and denominator, there's nothing special going on. We just need to focus on our denominator. And again, remember, whenever you have two terms in your denominator or a binomial, put parentheses around it. That means they're together. You're not able to simplify them at all. They go together. And same with your numerator. Those two are together. Now, in order to rationalize, you're going to multiply by the conjugate. And the conjugate is square root of 5 minus the square root of 7. And what you do to the bottom, you do to the top also. So square root of 5 minus the square root of 7. Now, our numerator, that's going to be FOIL, because we have a binomial times a binomial. So let's work that out first and simplify it all the way, and then we'll go back and multiply out our denominator. So square root of 5 times the square root of 5, that's our f, and we just get 5. Square root of 5 times negative square root of 7, our outside terms, well, it's going to be negative, and 5 times 7 is 35. Both numbers were inside, so we're going to leave 35 on the inside. Our inside terms, we have the square root of 7 times the square root of 5. Again, they're both inside, so I'm going to leave them inside. And I get the square root of 35. And it was a negative times a positive, so it's negative. It's my inside terms. And my last terms are going to be the square root of 7 times the square root of 7. Here, both signs are negative, so a negative times a negative is a positive. And then the square root of 7 times the square root of 7 is just 7. So first I want to simplify what we can. We see that we have 5 and a positive 7. So those can combine, those are like terms, to give us 12. Also, we see that we have a negative square root of 35 and a negative square root of 35. So those can combine. We keep that square root of 35 and we just combine the coefficients. Our coefficients here are 1 and 1. So negative 1 minus 1 is negative 2, and the like term square root of 35. So that's the simplified version of our numerator. For our denominator, again, we just have to do Florida. So square root of 5 times the square root of 5 is just 5. And we're just doing Floridas since they're conjugates. And then square root of 7 times negative square root of 7 is 7. And it was a positive times a negative, so we get a negative. Now 5 minus 7, that simplifies to negative 2. Now though, you have to look and see these three numbers, and it has to be all three of them. If they all three can be reduced by the same number, then you should reduce that. And we see that all of them we could divide by 2. So that's what we'll do. So dividing by 2, I get 12 divided by 2 is 6. Negative 2 divided by 2 is 1, square roots of 35. And negative 2 divided by 2 is negative 1. Now, we don't want to leave a negative in the denominator, and 1 is just itself. So we're just going to divide everything here by negative 1. So divide it by negative 1. We're going to divide this by negative 1, and we'll divide this again by negative 1. And when we do that, this turns into negative 6. This turns into positive 1 square roots of 35, and then it's over a positive 1, which we don't need to write. So here's our final answer. All right, last problem, number 20. Let's scroll down a little bit. All right, so we need to rationalize this denominator. We only have one term here. 6, we only have 1 6, and we need a total of 3 of them. So that means we need 2 more 6s. So I'm going to multiply here by the cubed root of 6 squared to get my 2 more 6s, 6 squared. Now in my numerator we have a binomial, so we want to put that in parentheses so we know to distribute. All right, so I know for my denominator I have 1 6 here, and then I got 2 6s over here. So now I have a group of 3 6s. So I have one group, so 1 6 comes out. And I'm done with my denominator for now. So in my numerator, I'm going to distribute 1 times anything as itself, so the cubed root of 6 squared. And I don't really want to leave it as 6 squared, so I'm going to write 36. And then the cubed root of 2 times the cubed root of 6 squared, well, it's going to be a plus sign since there's a plus sign here. And then, again, I don't want to leave it 6 squared. So 6 squared we said was 36, and 36 times 2 is 72. So I have the cubed root of 72. All right, so now we just need to see if we can simplify either numerators, either of those radicands. So 36, we'll break it up. 2 goes into that 18 times, 2 goes into that 9 times, 3 goes into 9 3 times, and 3 goes into 3 once. So we don't have any groups here of 3. So 36 is fine the way it is. 72, let's see here. 2 goes into 72, 36. 2 goes into 36 18 times. 2 goes into 18 9 times. 3 goes into 9 3 times. And 3 goes into 3 once. So for 72, we do have a group of 3 2's. So a 2 gets to come out, and these 2 3's have to go back inside. So this is really going to be the cubed root of 36 plus 2 times the cubed root of 3 times 3 is 9 over 6. And here's our final answer. We can't reduce this because the number in front of the cubed root of 36 is just 1, and the numbers 1, 2, and 6, they all don't reduce by the same number. So this is our final answer, and we are done with the study guide. All right, you guys, I hope you study up. Your test is tomorrow or Wednesday, depending on the ACT. So study, good luck, see you later.